So today's lesson is on writing equations and inequalities. So last time we talked about expressions which do not have an equal sign. Equations and inequalities are going to have either an inequality symbol or an equal sign. So first let's define equation. An equation is a mathematical sentence formed by placing the equal to symbol between two expressions. And an inequality is a mathematical sentence formed by placing one of the symbols, less than, greater than, less than or equal to, greater than or equal to, between two expressions. And then a new term that we'll talk about more, I believe it's in tomorrow's lesson, is an open sentence. Okay, is an equation or an inequality that contains an algebraic expression. So if it's an equation or an inequality with a variable in it, then it's what we call an open sentence. Okay, so down here, we're going to talk about these different symbols, what they mean, and then some words that are associated with them. So when you're taking word phrases and turning them into inequalities or equations, you'll have some kind of context clues here. So this first one means is equal to. Okay, and associated words would be like the same as, right? So if this said 5 equals 5, 5 is equal to 5, or 5 is the same as 5. Okay, so I think we're all pretty familiar with what an equal sign means. The next one means is less than. Okay, and associated words would be is fewer than, or even just fewer than, okay? And then next we have is greater than or equal to. Okay, so is greater than or equal to, and the associated words are at least. So if I told you that you had to make at least a 90, you have to make something that is greater than or equal to 90. Okay, next is less than or equal to, and that's at most. So for example, you can have, at most, if you can have at most 7 animals at your house, right? That means you have to have something that is less than or equal to 7 animals at your house. Okay, and this last one is greater than. Okay, and what that stands for is more than, or what another way of saying that is more than. Okay, and then when you have inequalities, sometimes you could have an inequality that's connected. So if I said X, let's just say X is how many hours of sleep you need, okay? It needs to be greater than 4, but less than 9. Okay, so we can combine this into one inequality where your sleep needs to be greater than 4 and less than 9. Okay, let's look at the back page. So let's look at letter A. We're going to write an equation or an inequality for each one of these phrases. So on letter A, it says the difference of twice the number k and 8 is 12. Okay, look at letter B. It says the product of 6 and a number, so product means multiply, so 6 times a number, that product is at least 24. So you have at least $24. That's greater than or equal to 24. Right? You could also refer back to the notes we took earlier. Okay, letter C says a number y is no less than 5 and no more than 13. Okay, so here's y. It can be no less than 5. So it has to be greater than 5. Could it be 5? Yes. Okay, and it could be no more than 13. Could it be 13? Yes. And then this one down here, the quotient of P and 12 is at least 30. So P divided by 12, and then at least, if you flip over and look at the notes on the front side, at least means greater than or equal to 30. So now it says if you substitute a number for a variable and the statement is true, the number is a solution. Okay, it's a solution if you plug it in and it makes it true. So it says check whether 3 is a solution of the equation or inequality. So for 3, I'm going to plug it in down here. 8 minus 2 times 3 equals 2. So 2 times 3 is 6. 8 minus 6 equals 2. So what's 8 minus 6? 2. So does 2 equal 2? Yes. So therefore, it's a solution. Okay, look at this next one. If I plug a 3 in here, I have 4 times 3 minus 5 equals 6. So 4 times 3 is 12. 12 minus 5 is 7. Is that a true statement? Does 7 equal 6? No. So therefore, it is not a solution. When I plugged 3 in, I substituted it. It did not make a true statement, so therefore it's not a solution. Okay, on this one, I'm going to plug it in here. 2 times 3 plus 5 is greater than 12. So 2 times 3 is 6. 6 plus 5 is 11. Is 11 greater than 12? No. 11 is not greater than 12. So therefore, it is not a solution. And then this last one, I have 5 plus 3 times 3 is less than or equal to 20. So 3 times 3 is 9. 9 plus 5 is 14. Is 14 less than or equal to 20? Yes. So it's a solution. And then 2 more examples. The last time you and your 3 friends went to a mountain bike park, you had a coupon for $10 off, and you paid $17 for 4 tickets. What is the regular price of each ticket? Okay, so let's do 4 times the regular price, right? Less the $17 or the $10 coupon was $17. So that means that before the coupon, 4 tickets would have been $27. So now I'm trying to figure out how much each ticket is. So I'm going to do 27 divided by 4. 4 goes into 27 6 times. 6 times 4 is 24. That's a 3. 4 goes into 37 times. That's 28. And 4 goes into 25 times. So each of the tickets is $6.75. And then this last one, a basketball player scored 351 points last year. If the player plays 18 games, will an average of 20 points per game be enough to beat last year's total? So 18 games times 20 points, will that be greater than 351? So I know 18 times 2 is 36. So 18 times 20 is 360. Is 360 greater than 351? Yes.